Today we'll be in Chapter 2 with functions and graphs. We'll be talking about combinations of functions and composite functions, and this is part 1 of 2.6. Our objectives will be to find the domain of a function, combine functions using the algebra of functions and specifying domains, form composite functions, determine domains for composite functions, and write functions as compositions. We'll start by finding a function's domain. So if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So you need to exclude anything that causes division by 0. So if you ended up with something like 6 divided by 0, that's going to say error on a calculator, so that's not allowed for a function's domain. Remember, the domain are all the x values. And real numbers that result in an even root, like a square root of a negative number, would also say error. So let's say I want to do the square root of -4. That's going to say error. You cannot take the square root of a negative number. You also can't take the 4th root of a negative number. That's not allowed. So that's what it means by even root of a negative number. So here's an example. So it wants us to find the domain of this function. G of x equals 5x divided by x squared minus 49. So the solution of this is below. It says because division by 0 is undefined, we need to exclude anything from the domain that would give values of x that cause the denominator to equal 0. So we're saying this bottom part, let's just look at the bottom, cannot equal 0. So if you solve that out, x squared minus 49 cannot equal 0. If we finish solving that, we get x squared cannot equal 49. So the square roots that would give you 49 would be x cannot equal 7 or -7, or you could say plus or minus 7. So I'm going to show you on a number line how to make sense of this. So we're saying that it cannot be 7 or -7. Those are the only things that don't work. So let's just think of a number line here. If I put -7 here, let's put 0 in the middle, +7 here. Anything below -7 is going to work. So that's where this piece comes in. Anything from -infinity up to -7, that's going to work, and then you can put a parenthesis there. And then anything between negative and 7 will work. You just can't include -7 and 7. So that's why I'm going to leave it as a parenthesis. Anything between. Let me do that in a different color so you can see it a little better. So again, I'm not using the brackets because brackets would mean it could include -7 and 7. It cannot include those. And then we also have anything from 7 up to infinity would work, but not including 7. So it's the union of all of those, but we have parentheses because it cannot include the -7 and 7. It could be 7.1, but it can't be exactly 7. Okay, let's try another one. So this one says find the domain of this function, f of x equals x squared minus 7x. So if we think back to our rules, we can't have division by 0. We also cannot have the square root of a negative number. So this is not going to involve anything. So that means any real number. I'm saying real number because there is such a thing as imaginary numbers. We're not going to be talking about those today. Any real number x will work. So the domain of f would equal -infinity to +infinity. So it'd be the whole number line all the way to positive infinity and negative infinity. There's no restrictions on this one because we don't have the square root of a negative number or division by 0. Okay, let's try this one. So again, we aren't going to have a square root involved, but we do have a denominator. And we know this denominator cannot equal 0. So we're going to try to solve for x. What x's would make this equal 0? Okay, so this is going to be a factoring question because I have a trinomial here. So remember, you're trying to think of factors of -3 that will add to -2. So if I do -3 times +1, that's going to give me -2 when I add it. So I'm going to have x squared minus 3, and then x plus 1. And if you did FOIL there, you would get the x squared. So if we continue this, this means that we would have x minus 3 cannot equal 0, or x plus 1 cannot equal 0. So that would mean if I solve it, x cannot equal 3, or x cannot equal -1. Okay, let's try to think of what our number line is going to look like on this one. So the only restricted values are the 3 and the -1. So let's just put a -1 here, 0, 1, 2, 3. You could put more numbers, I'll just put those. So it could be anything leading up to the -1, but it can't be exactly -1. So far we have negative infinity to -1 is going to work. Then we'll have the union of where that meets up. X cannot equal 3 either, so it could be anything above 3, but not exactly 3. So that's going to be my last one. So 3 to positive infinity would work. And I have my parentheses. Now I'm trying to find this in-between portion. I didn't do that yet. So from -1 to 3 is also possible, it just can't be exactly -1 or positive 3. So I'm going to have parentheses. So here is my final answer. And again, I think the number lines help to understand this, and I should shade in between, showing that anything in between that is going to work. And I think that helps you when you're going to write the interval notation. Square root of 14 minus 2x. So on this one we know that we cannot have the square root of a negative number. No negative square roots. So we know that this under here has to be greater than or exactly equal to 0. So that's going to be our formula. The portion under the square root has to be greater than or equal to 0. So if I minus the 14, I get -2x has to be greater than or equal to -14. Divide by -2. Now be careful here. When you divide by a negative, you have to flip the sign around. So x has to be less than or equal to 7. So on our number line, if I had 0, then let's say 7 is up here. Has to be less than or exactly 7. So I can put a bracket on this one. So the domain of H equals -infinity all the way up to +7. And I'm going to close it with a bracket. Now I want to show you why the things in the red work and why the things not in red will not work. So let's just pick, let's do right here, that would be 6 approximately. That is in the red, so we're saying that should work. It should make this true. So if I tried plugging in a 6 here, the square root of 14 minus 2 times 6 would leave me with the square root of 14 minus 12, which is the square root of 2. You're going to get a decimal, but it is a possible answer. So that checks out. Now let's try something not in the red. Let's try the number 8. Let's see why 8 is not shaded. So if I do the square root of 14 minus 2 times x, which we're saying is 8, I'd get the square root of 14 minus 16, which is the square root of -2, which is not possible. So that's why anything not in the red is not going to work. Anything above 7 is not possible for this square root. Okay, now we're going to be talking about sum, difference, product, and quotient of functions. So we're going to use f and g for our two functions for our examples. So if we look at our sum, f plus g, you can break it into f of x plus the g of x. The difference formula, you can subtract them from each other. The product, you multiply the two functions together. And the quotient, you divide the two functions together. And again, the denominator, this bottom part, cannot equal 0. So that's why this one has that thrown at the end. And this part, again, this means the intersection, the domain of f, and where it intersects the domain of g. So we'll look at some examples to make sense of these problems. Okay, so let's try this one. We have our function f of x is going to be 2x minus 1. G of x is going to be x squared plus x minus 2. We're going to know what is f minus g of x. So if you look back at that other slide, we said this can be written as the f of x minus the g of x. And it has to be that order since the f came first. So we're simply going to take f of x and put it here minus g of x. Let me do that in a different color. And you have to minus that whole quantity. And then you simplify. So I'm going to change all these to their opposites right away so I don't forget. So I'd have 2x minus 1. Then I have plus a negative x squared plus a negative x plus 2. I can put my x's together and my -1 and my +2 together. So I'll have negative x squared first. 2x minus x is positive 1x. -1 plus 2 is positive 1. So that's what we get when we find f minus g of x. Okay, we also are going to talk about the domain of this. So the domain of this is going to be -infinity to infinity because The f has no restrictions here. 2x minus 1 doesn't have any division by 0 or negative square root possibilities. And same with this one. So we just have negative infinity to positive infinity would work for all the possible x values. Okay, now we're going to try the product formula. So f times g of x. So that is the same as f of x times g of x. So I'm going to take my f of x times my g of x. So I'm going to apply the distributive. You think of FOIL on this one, but there's a binomial and a trinomial. So 2x times x squared would be 2x to the third. 2x times x would be positive 2x squared. 2x times negative 2 would be negative 4x. Then let's do this part. Negative 1 times x squared is negative 1x squared. Negative 1 times positive x is negative 1x. Negative 1 times negative 2 is positive 2. And now I'll combine any like terms I have. So I have 2x squared and minus x squared. And I could put my negative 4x with my negative 1x. So simplified, that'd be 2x to the third. 2x squared minus 1x squared is positive 1x squared, or you could just put x squared. Negative 4 minus 1 is negative 5x, then plus 2. So f times g of x equals this 2x to the third plus x squared minus 5x plus 2. Now this also has no restrictions. Negative infinity to positive infinity would be my domain. Because if I look back at my original, again, there's no issues there with negative square roots or dividing by 0. Okay, now we'll apply the quotient formula. So on this one, I'm going to have whatever f of x is divided by g of x. So that would be f of x is 2x minus 1. G of x is x squared plus x minus 2. So now we need to see if this can be simplified. So if I look at my bottom part, this is like a 1x. So I'm trying to find factors of negative 2 that would add to positive 1. So I'd have 2 and negative 1. That would multiply to negative 2 and add to be positive 1. So on the bottom, I could change it to an x plus 2 and an x minus 1 because of these two numbers I found. But that did not help me simplify it at all. So for my final answer, I am just going to leave it as the quotient of f divided by g of x equals 2x minus 1 over x squared plus x minus 2. I can leave it like that because I tried simplifying and nothing could reduce out. Now the domain of this, I actually just helped myself with the bottom part because I know that the bottom cannot equal 0. That is not allowed. We cannot have a denominator of 0. So if we look right here, we're saying this cannot equal 0. Now I just factored it over here, so that's going to make it easier because I'm saying the x plus 2 times the x minus 1 cannot equal 0. So that means x plus 2 cannot equal 0, and x minus 1 cannot equal 0. So I'm going to get x cannot equal negative 2 and x cannot equal positive 1. So now to write this in interval notation, if I think of a number line, I can go up to negative 2, but I can't include negative 2. Then I can go to positive 1, but I cannot include positive 1. So it's everything but the negative 2 and the 1. So I can also include what is in the middle. So I'd have negative infinity up to negative 2, parentheses, then the union of negative 2 up to positive 1, then the union of 1 to positive infinity. So that would be my domain right here. And I have another one here that you can go back and look at. So this one is addition, and I'm using a different f of x and a different g of x on this one. So for f plus g, the sum, you just take f of x plus g of x. So I'm going to take the f of x was x minus 5, g of x is x squared minus 1. You can combine the negative 5 and the negative 1 into negative 6. So this is the answer on this one. And neither one of these, this one and this one, do not have any restrictions. And this final answer has no restrictions. So our domain is negative infinity to positive infinity. Okay, let's try applying that some more. So this time I have square root of x plus 3, and then g of x is the square root of x minus 2. So we want to find the sum of those and then find the domain. So first let's find the sum of those and then we'll worry about the domain. So I'm going to take f of x plus g of x. So f of x is the square root of x plus 3. G of x is the square root of x minus 2. And there's actually nothing else I can do on that, so that is my answer. Now the domain's going to be a little trickier on this one because I have some square roots involved. So I'm going to find each domain, then their intersection to see what is common to both the domain of f and g. So we know that what's underneath the radical has to be greater than or equal to 0. So x plus 3 has to be greater than or equal to 0. So that means that x has to be greater than or equal to negative 3. And then if I do my other one, again, this has to be greater than or equal to 0. So x minus 2 has to be greater than or equal to 0, so it's not a negative result. So x has to be greater than or equal to 2. Okay, so if I look at my number line, let's just put negative 3 here, 0, and 2. We know that it could be anything greater than or equal to negative 3. So I'm going to shade above for now so we can then find the intersection. Or it could be anything greater or equal to 2. So we want to know what is common to both. That is their intersection. So the point where they intersect is from here and above, right? So anything below 2 is not going to work for this formula. Because if I put a 1 in there, 1 minus 2 is -1. We cannot do the square root of a -1. So it's only where they have in common that is going to work. So it's going to be anything greater than or equal to 2. And you can write that as 2 with a bracket all the way to infinity. So that is our domain on this one. Okay, let's do an application problem. So these are functions that model the number of births and deaths in the U.S. from 2000 to 2011. So the B of X formula is for births, the D of X formula is for deaths. So A says write a function that models the change in U.S. population from 2000 to 2011. So we know population changes by taking how many births there are per year minus the amount of deaths. So you're hoping there's more births than deaths, so you keep increasing in population. So you can model that by saying we're going to take the number of births minus the number of deaths. We're going to use our difference formula. And that is the same thing as B of X, the births, minus the amount of deaths. So if I'm going to write it over here so I don't run out of room. B of X is negative 2.6x squared plus 49x plus 3,994. Then I'm going to subtract D of X. So make sure you subtract the entire quantity. So I'm going to change these into their opposites. And then combine my like terms. I can put this together. That leaves me with negative 2x squared. I can put 49x minus 7x would be positive 42x. Then 3,994 minus 2,412 is 1,582. So that is our birth minus death function formula. Okay, now we're going to take that formula and try to apply it to the year 2008. So remember, this is from 2000 to 2011. So 2008 is 8 years after 2000. So x is going to equal 8. That's what we're going to be replacing in our formula. So if you remember our formula on the last slide, it was negative 2x squared plus 42x and I'm going to replace our x with an 8. I want to know what is it when the x is 8. So wherever I see an x, I'm going to put 8. and then go ahead and simplify. So I have negative 2 times 64 is negative 128. 42 times 8 is 336, plus 1,582. If I add those together, I get 1,790. Now you have to be careful here. This is in thousands. So 1,790,000, or it's 1,790, then 1,000 means 3 more zeros. So that would be how many people we have in 2008. And our last part, does the result in part B that we just said overestimate or underestimate the actual population change in 2008 from the graph, and by how much? So we just said that there was 1,790,000 people is how much the population changed. Or you could say 1,790,000. So now let's find this in the graph. We're looking at 2008. So births are red, deaths are yellow. So we have 4,247 minus 2,453. And that's 1,794,000. Or 1,794,000. Okay, so does the result in part B, this was our part B, overestimate or underestimate? It actually underestimated the actual population change, because it was actually 1,794,000. And we thought it would be 1,790,000, so we were very close, but not completely accurate. So if I subtract those, it's going to be a difference of 4,000. So we underestimated by 4,000. And I need to put a label. That is people. Okay, that is the end of part 1, and part 2 will be in your next video.